Greetings. Let's differentiate a few functions using the product rule. So this is quite an important rule for differentiation, and the idea lies in that of course I can have a function, a usual function a of x, and if I take the derivative of it, then it becomes, I can write it as a prime of x, right? And if I say that a of x is further equal to the product of two functions, so a of x is equivalent to the situation when the function f of x and g of x, both in respect to the same x, are multiplied by each other, then if I derive a of x, the question is, or in other words, the same I did above here, d over dx, the question is, what do I get? Do I get like f prime x, g prime x? Not really. And that's the point of this video, that's the point of product rule. When a function that is further equal to the product of two other functions is derivated as a whole, then the entire thing is derivated as follows. I just have to put both of these, this entire product expression, into the derivative operator as well. And what the product rule answers is what is actually going to come out of this. So the product rule says it clear. The product rule says that the result of such a derivation when two functions are multiplied by each other, but as a whole derivated, the result of this will be derivative of the first one times unchanged second one. And then switch the polarity of this idea, and then underrated first one, unchanged, times the derivative of the second one. So of course one can do it the other way around. One can do unchanged first one times derivative of the second one, using exactly this, plus changed first one, derivative first one times unchanged second one. Where f of x is the first one and g of x is the second one, one can call the two arbitrary functions however one wants. But of course, this works in general. This is a general rule that works always. And so let me just show a few examples. Let's say you will test it out on 3 examples and just see that it does work very well. Alright, so the idea is I am just trying to figure out the derivative of a function which is actually made up of two functions in a product with each other. And so let's say the first example will be sine x times x squared. Alright, so I'll put both into parentheses so it's visible they are separated, but yet they are in product together, and I'm taking the derivative of this entire thing. So I'm saying the entire function is not just sine x times x squared, but just sine x and x squared is another one, but in the sine x times x squared is the entire function. Of course, not to confuse the x squared with the argument of sine. The argument of sine is only x in this case, alright? So the point is again the same thing. Derive one and multiply by unchanged second one, change the order of things, and then derive the one that has not been derived yet and not change the one that had been derived before. So this ends up being, for example, I can start by first deriving the first one. So this, when I derive the product of two functions as a single one-way function, I get derivative of the first one, which is sine x, derivative is cosine x, and unchanged second one. And to that, I add unchanged first one because I had changed the first one before, and I do change the second one. Alright, so this is my result. This is the complete result. I don't really see much way one can further write this. Of course, for it to be more clear, maybe it's nicer to write the polynomial part, this x squared, in front of the cosine x. So I don't need parentheses for everything to be clear, and then 2x sine x right here. Now maybe it looks even clearer, alright? And cleaner. So this is the first example. I can continue with the second example. And in this case, I will actually show that it is interchangeable to use either this or a different realization. Because before it might have, of course, happened that one would, for example, x cubed times 2x squared. Alright? So there's function 2x squared and x cubed. And what one can do is also use the product rule, or when one does not want to use the product rule or doesn't know it yet, it's possible to just combine these two functions when it is possible. With the sine and x squared, not really. But with this one, it is highly possible to just combine it into one term. So I can of course say that this same thing is d over dx, so the derivative operator applied to not this, but I can write it by adding up the exponents and taking the common, this one constant multiple out. Or just realizing I can move out the constant multiple for both and then add the exponents for same basis, which both are x. So I get 2x to the same thing, right? Instead of having two functions, x cubed and 2x squared, separated, I can put them together into one term, which is possible with these simple ones. But with some other ones, like the one I just did before, it was not possible, and therefore product rule was indeed required. So in such case, I can just apply simple power rule, which tells me 12x to the fourth will be the result right here. All right, 10x to the fourth will be the result right here. Or I can use the product rule and show that indeed, so I will write 10x to the fourth is what I got through realizing that I can combine it into one term, and now I can show that I can reach the same result by using the product rule. So d over dx, and then I can use the product rule of this thing. So let me not write it again, I will just write the process of calculating it already. So again, I can write it out in that longer way and use a systematic way to get to the same result. So deriving the first one will be 3x squared, and leaving the second one as it was is 2x squared. Right, so I already see this will be giving me 6x to the fourth, so only I need 4x to the fourth left. So in the second part, I'm adding unchanged first one, and I derive this one, which is 4x. I derive the second one while leaving the first one as it was. This gives me 6x to the fourth plus 4x to the fourth, and indeed this equals exactly 10x to the fourth. So as one can see, the result is same regardless whether if one changes it into one term and simplifies it and only apply the simple derivation rule, or uses the extended product rule by not putting these two functions together into one. And the third result, or the third example that I will come to right now, will be probably one of it won't be much harder than the previous one, but still, I just won't use in this case a polynomial function or anything simple like that. I will simply use ln x and cosine x, just to make things slightly more interesting for them. So there really won't be any numbers, and what I will do is I'll just start using the rule. So the rule tells me derive the first one and leave the second one as it was, plus leave the first one and derive the second one. So derivation of ln x is 1 over x, and leaving the second one as it was is cosine x. And then to that I add unchanged first one, which had been changed before, and I multiply it by indeed derivative cosine x, which gives minus sine x. Right, so I can combine this into a simpler algebraic expression, and I yield this yields ln x sine x as follows. Alright, these of course have their own arguments not to combine together. Alright, so this is the result for the third example of the product rule.